Good morning, everyone, and welcome to the June edition of the Southeast Climate Monthly webinar, where we talk about the climate and special topics pertaining to the Southeast region. I'm Sandra Rain, the Regional Climatologist from the Southeast Regional Climate Center, and I will be giving a climate overview. Our guest speakers today are Jeff Dober from the Southeast River Forecast Center, who will provide a water resources overview, Pam Knox from the University of Georgia, who will give an agricultural impact update, and our special topics, the 2022 Hurricane Outlook presented by Matthew Rosenkrantz from NOAA's Climate Prediction Center. We thank everyone for joining us. Just a reminder before we begin to type all of your questions in the question box at any time, and they will all be answered at the end. Also, an email with a YouTube link to this recording, as well as a link to the summary of today's webinar, will be sent out in the next day or two. Okay, let's talk about the climate. Temperatures over the past 30 days have been above average across most of the region, with much of the Southeast seeing upwards of 2 degrees above normal. We have seen many places reach 100 degrees on June 22nd and 23rd. Raleigh tied a high temperature record on June 22nd at 100 degrees, which was last set in 1981, and Macon, Georgia hit 105 degrees, which was a new high record for the day. Precipitation over the past 30 days has been much below average across much of the region, except for southern Florida. Monthly precipitation totals range from 50 to less than 25% of normal in parts of Alabama, Georgia, and the Carolinas. Just a reminder, though, this is the time of year where we see our greatest chances of severe weather, and we could definitely use some rainfall across the Southeast. Speaking of rain, parts of Florida saw some heavy rain from Tropical Storm Alex at the beginning of the month. Alex was our first named storm of the season and produced winds up to 70 miles per hour. Miami, Florida reported over 11 inches of rainfall from the storm, and Naples had close to 9 inches. For our tropical outlook, we can see that there is a disturbance near the Windward Islands, and this is projected to become a tropical storm within the next day or two. Moving on to the ENSO update, we're still under a La Niña advisory with a 52% chance of La Niña continuing from July through September and a 58 to 59% chance of La Niña continuing through the fall and early winter. So there is a possibility that we may see our third La Niña in a row this coming winter. The U.S. Drought Monitor continues to show some exceptional drought in the western part of the United States and southward into parts of Texas, and the outlook has the drought continuing in much of the West, which will continue to exacerbate their water issues and fire potential. Here in the Southeast, drought conditions have increased with severe drought in eastern North Carolina and at the Georgia-South Carolina border, and moderate drought stretching from North Carolina down into Georgia. The Caribbean is also dry with severe and moderate drought seen across Puerto Rico and severe to extreme drought across parts of the Virgin Islands. The Lawn and Garden Index continues to show the dry conditions across the Southeast as well. Fortunately, the drought is expected to improve across all areas of the Southeast as we go through the rest of the summer. For the next 3 months, we have the probability of seeing above normal temperatures across the region, with the probability of wetter conditions stretching down from Virginia to the Florida Panhandle and equal chances of wetter or drier conditions across the rest of the Southeast. But for the holiday outlook from July 2nd to 6th, there is a probability of above average temperatures for the region, as well as a probability of above average precipitation for Virginia and North Carolina, with near normal chances elsewhere. And speaking of precipitation, hopefully we'll see some through the rest of this week. The heaviest amounts look to occur in the Florida Panhandle, Alabama, and southern Georgia, but any amounts are welcomed everywhere. Okay, to sum up, the Southeast has been above average temperatures for the past 30 days. Precipitation has been below normal for the Southeast. Tropical Storm Alex was our first named storm of the season. We continue to be under a La Niña advisory and will likely see our third La Niña winter in a row. Drought is observed in the eastern Carolinas and Georgia, but is expected to improve. Precipitation is likely through this week, and the next 3 months will likely be warmer than normal, and with wetter than normal chances from Virginia down to the Florida Panhandle, and equal chances of wetter or drier conditions elsewhere. And with that, I'll turn it over to Jeff.
Alrighty, thank you, Sandra. And not much has changed from our May outlook that we had early last month as far as water resources. We'll go to the next slide and show you what's going on here. We have seen a slight decline in stream flows across the southeast over the last several weeks with the drier weather that Sandra talked about, mostly across Georgia and the Carolinas and southern Virginia. As you can see on the map there to the left, a lot more of those orange dots that we didn't see back in May. And there to the right, you see the duration hydrograph, the 28-day average, basically average stream flows. And we're treading right through that normal to below normal range across the region at the current time. Go to the next slide and break it down state by state and show you what stream flows are looking like. Again, for Alabama, relatively in that near normal range, that green range there, but falling off considerably since that our wet April period across most of the states. Georgia, the same signal there, treading right around the near normal to slightly below normal range as we're dipping into those orange colors. And then as you see in Florida, a little bit of a different beast as stream flows typically increase, especially in the peninsula this time of year with the wet season beginning. But in Florida, we're looking at near normal stream flows as an average. Going to the east now, in the next slide, we'll go into the Carolinas and see that South Carolina and North Carolina treading in that slightly below normal range. And then Virginia, again, in the normal range. So stream flows typically falling off this time of year as we're in that benign summertime period for rainfall and stream flow. And we'll go to the next slide and show you the current conditions across our area as far as flood impacts. Right now, no flood impacts have been seen, and we really haven't seen much flooding at all over the last several weeks. Which is pretty typical this time of year. With that being said, here's the flood climatology, and we go to the next slide. And we see we're in week 26, and on average for the Southeast US, as I said, we're in that benign period where we're in the sort of river flood climatology lull, the summer lull here on average for most of the Southeast, and we don't really start picking up really toward the late summer and early fall. But that's for the entire Southeast. The only exception, if we go to the next slide, is the Florida Peninsula, where wet season begins. They're, again, slightly different than the interior Southeast, and we're in week 26. And typically this is when we start to see the rains begin, the convective rains begin, and we have seen some in the Florida Peninsula. And alongside of that, we start to see flooding pick up. So we're sort of in the beginning period of that potential flood season, but we're not seeing anything that as of right now, not really seeing any chance of that in the Florida Peninsula. Usually it's around the Tampa area. You know, they have a lot of smaller coastal rivers. Sometimes we start to see some flooding pick up around that area, but we haven't seen that so far. Going to the next slide, and this basically showing our late summer flood outlook, July, August, and September. Again, we're calling for near normal risk of river flooding, which is pretty low for the interior Southeast during what we call our low season risk, and near normal for the Florida Peninsula, which is sort of their high season. We're going into their high season risk, but it looks relatively wetter over the next couple of weeks, as Sandra pointed out, maybe slightly above normal for especially the Carolinas. with the increased thunderstorm activity. And this will keep us probably in those near normal stream flows as well as near normal flood risk for most of the area. So again, the real caveat here as we go into this period is the potential for tropical season activity. And that usually picks up, what we find is June is somewhat of an active chance period for that kind of activity. And then we sort of fall into a little bit of a lull during July. And then by late August, September, we start to pick up as far as the southeast, those chances or that threat starts to pick up as far as heavy rainfall. And so on the back end of this summer flood outlook period, we'll be watching that closely. And so that is the final slide. So in summary, 28-day USGS stream flows are slightly below to near normal across most of the southeast. And we'll see stream flows, they're going to typically fall off this time of year, as I said, except that Florida Peninsula area. And then what we're expecting is stream flows to continue as an average in the normal range, but there will be some variability. Again, we'll have pockets of above and below normal. We'll have some of the smaller coastal rivers continue to have issues with stream flows, and then maybe some smaller rivers fall in that above normal range as well. So there will be some variability. So that's all I have, and I'm going to have to I'll pass it off to Pam.
All right. Well, good morning, everybody, and thanks, Jeff. Good to see, or I guess to know that you're there, even if I can't see you. Agriculture right now is going crazy. Here at our research facility in Watkinsville, we're having our sweet corn boil today, so I'm looking forward to having sweet corn for lunch today. If we move to our first slide. Here we go. It's not that unusual to have a dry spell this time of year, but it really causes a lot of problems for agriculture, as you can imagine. This is from the Perspectives tool at the Southeast Regional Climate Center, and it shows the ranking of the precipitation for the last 2 weeks. You can see a lot of brown boxes there that indicate it's in the top 5 or 10 driest for this time of year periods. And that's really tough because plants need regular water. And with the really warm temperatures that we've had, there's been a lot of stress on the plants. And we're seeing that in agriculture this year. So if we move on, just a look at soil temperature and moisture, you can see the lack of cloud cover associated with no rain, and the very hot conditions have led to soil temperatures that's a lot hotter than usual. And the soil moisture, of course, has always also been quite low because not only do we have evaporation from the soil, but the plants are using up every bit of water that they can scrape out of the soils. And so the evapotranspiration is also very, very active. A lot of farmers, if they have access to irrigation, are putting out as much water as they can to keep things going. If we move on, some of the impacts of the recent conditions on agriculture, dry conditions across not only Georgia, but really most of the Southeast have caused a problem. The pastures have really pretty much shut down as far as producing grass. And so farmers are having to feed a lot of hay. Usually they don't have to do that much of it this time of year, but that's cutting into their hay stocks. And of course, at the end of winter, they're usually pretty reduced anyway. Many producers did get in one cutting of hay, but they're having trouble getting a second in because there's just not much growing right now. We do know that the dry spell in parts of eastern Alabama and western Georgia during a really peak period. This is pollination period, and if the silk is too dry, the pollen won't stick to it, and they lose their whole crop. The corn may still be growing, but there's no kernels in the ears, and so we think at least some of the dryland corn is probably going to be a complete loss due to that unfortunate timing of the dry spell right at pollination. We saw that back in 2016 with that drought as well. Heat is causing issues with the fruit harvest. Fruit doesn't like it when it's really, really hot, and so there's less fruit set on the tomatoes and cucumbers and other associated vegetables like that. Also causing some problems, I suppose, for the people that are out working in that heat, as well as the livestock that have to deal with the heat. But farmers are taking advantage of trying to provide shade for their animals and taking breaks watching the temperature and humidity carefully. We do see, not unexpected, disease and pest pressure are both increasing. Diseases tend to be more associated with wetter conditions where you get more fungal diseases, pests more when it's drier. But depending on where you are, both of those are increasing. We've seen a lot of increase in white mold and peanuts and southern corn rust, which is just exploding across the southern part of the region. And so that is really something we're watching carefully. And the conditions are a little bit less severe in other parts of the southeast, but the heat and drying is definitely still of concern in many places. You can see a couple of pictures here, the corn rust damage to corn leaves, and then there was also some hail damage. If you have enough hail, of course, it strips the leaves off the plants and it causes problems with yield, but this is just pretty cosmetic, so not too much severe problems from hail, at least so far. If we move on, I just wanted to mention, and I've mentioned this, I think, before, the condition monitoring reports is a way that extension agents and producers have to communicate what they're seeing out the back window to the authors of the National U.S. Drought Monitor. And I've been really pushing this to the choir here in Georgia. You can see it's paid off because we have all these reports from people in Georgia and also quite a few in South Carolina. There is a way to report your conditions, and it really helps the authors, because they're located not in the southeast, so they really appreciate having the chance to see what's happening on the ground. I think Lucy Ray, who's the extension agent in Morgan County, which is just south of Athens, got almost every single one of her producers to send in a report, which you can see in the map here. Most of these reports were sent in the last week, but I did include everything for the last month just to show you what's going on. And so I encourage you, especially if you're in other states and you're experiencing dry conditions, to go and put these reports in. They're definitely appreciated, and they're definitely used when the Drought Monitor authors put together those maps. And so you can see that there, and I hope to see a lot more in the next month. If we go on, just looking ahead a little bit, it looks like the real dry spell is probably broken down. The high pressure is broken on, and we're getting more typical summer pattern, which means more frequent afternoon showers. Now, not everywhere gets hit every time, but over the course of a week or so, most areas should get hit by at least some rain. So that'll be very helpful. Warmer than normal conditions are continuing to be expected for the next 4 weeks. There'll be some periods like today with the front having come through where it'll be a little cooler, but certainly it's going to be warmer than normal overall. And I will say the long-range models are not showing any significant tropical activity in our area, but I did notice this morning when I looked at the projected radar loop for this little potential area of development off the Louisiana and Texas coast that some of the models do have it circling back towards the southeast. So we probably won't see a tropical storm out of it, but we might see some tropical rain, and I think that would be pretty welcome. If we go on, the summary that I've got here is drought intensity has increased due to the lack of rain and the very hot temperatures. Dryland corn definitely in some places will probably see a total loss. Don't know if that's a sign of what's going to happen later this year. It depends on the tropics, and we can't really predict that. Pest and disease pressure are increasing, and next 2 weeks we should see continued warm conditions, maybe not quite as hot as we saw earlier, and a return to more frequent daily rains, which will be very welcome. And just a reminder, the tropics are starting to wake up, even though we don't see a storm headed right for us, and it's definitely time to prepare if you haven't yet. So with that, I will stop and thank you. If you got any questions, you're welcome to ask at the end of the webinar, and turn it over to our guest speaker.
I am waiting for my webcam to come up. All right, I think it's up. Great. So we can just, hi, I'm Matt Rosencrantz. I'm here to talk about this 2022 seasonal hurricane outlook. So if you can go to the next slide, we'll get moving. Yeah, so just to review, the hurricane season in the Atlantic does start on the 1st of June officially and goes through the 30th of November. We have had one named storm, Alex, as was mentioned before, and that was in early June. and that is about a little bit ahead of schedule. The first named storm in the Atlantic, climatologically, when defining climatology is 1991 to 2020, forms June 20th. The second named storm would be July 17th. That is the average date of the second named storm. So if the current storm or the current investigation area and potential tropical cyclone is out there, does form the next week, we will continue to be ahead of schedule for this season. If you have interest in the Eastern Pacific, 15th of May till the 30th of November. And the Eastern Pacific is interesting because some of those storms can actually come up, recurve across Mexico, and bring a bunch of late season moisture into the kind of southern plains and then across the southeast. So you can have kind of remote impacts from the East Pacific tropical cyclone activity. Next slide. So just reviewing some climatology and when we do these outlooks, we do one of the outlooks the end of May, and that's very much before the beginning of the Atlantic hurricane season, where June and July, as you know, they have on average one storm. Then your activity really starts to ramp up in the Atlantic in August, in which 90% of your activity happens after August 1st, and about 75% of your activity happens after August 20th in the Atlantic basin. So it's a very peaked formation periods. So that's what we do an Atlantic update, in which we are targeting right now to do that update in early August. So it's anytime between August 4th and kind of August 12th. That's when we will release that outlook. It really does depend on exactly when the model runs come off the supercomputer and when the team, the Hurricane Center, and I can meet and just make the outlook. For the Eastern Pacific, we released the outlook in early June, or excuse me, late May, coincident with the Atlantic outlook, but there is no update for the Eastern Pacific. Next slide. So just want to review kind of climatology before we start talking, this is looking backwards before we start talking about looking forward. If you look in the upper left map in July, you get a lot of formations and tracks kind of through the Gulf of Mexico and up along the east coast of the US, with the potential for some to form in the kind of the Eastern Caribbean, kind of where we're looking at potential tropical cyclone 2 right now, if that does develop. There is also a little bit of a linkage for early season formations deep in the tropics being related to active seasons, especially when they form out near the Windward Islands. Western Caribbean and Gulf of Mexico formations are not so much linked to overall seasonal activity. But then as we get to August and September, that's when you get those, when you're more apt to get those long track storms that kind of form deep in the tropics and take those kind of big sweeping arcs up towards the southeast. It's also the season when you're more likely to get rapidly intensifying storms, which is when the storms go from, they add a lot of strength within 24 hours, and that is currently a very big issue, and issuing watches and warnings for those. So preparing now can give you more time to prepare for a storm later. Give more time to respond to a storm later. As we get to October, you do tend to see a bunch more formations, kind of shifting back towards the Gulf of Mexico, potentially impacting the southeast. A lot of those late season formations are also along old cold fronts that will come with a change of season. You get cold fronts that kind of push into the southeast, and then as those fronts hang over the Gulf of Mexico, you can actually get them to develop and transition into tropical storms, some waves along those fronts. So next slide. This is a map of the formation or the landfall areas, kind of your highest areas, no surprise, southern Florida. Those are your most frequently impacted areas from tropical cyclones. So this is about 100 years of data, and there have been, 20 on average about 30 strikes. Well, there's been 30 up to 32 strikes in Southwest Florida. So that's about one every 3 years. If you look in kind of North Carolina, the Outer Banks and the eastern parts of North Carolina, there's a storm there that hurricane strike every 5 years. Now this is only hurricanes. This isn't tropical storms. Tropical storms would be even more frequent because tropical storms, there's about 50% of tropical storms become hurricanes. That's an average. And then the other large area formations are landfalls from hurricanes is also kind of stretching from about Houston over to about Mobile, Alabama. Those are some areas with a lot of high amounts of landfalls. And that's been specifically the past couple of years, we've had a lot of landfalls in that region. There's been more category 3, 4, and 5 landfalls since from 2017 to 2021, as there was from 1963 all the way up through 2016. So we've had a lot of landfalling storms that are a lot of major hurricanes recently. So if you're not imagining that it's been busier, it has actually been busier. Next slide. So that's the past. Going to this year for the future, we are expecting 14 to 21 named storms, which we've already had 1, and we have a potential for 2 coming up. 6 to 10 hurricanes, and 3 to 6 major hurricanes. Major hurricanes are winds of 111 miles per hour at the center of the storm, or actually in the eye wall. So it's not everywhere the storm's going to have 100 miles an hour. It'll be closer to the center of the storm, and then that kind of weakens as you go out. But it does mean you could still end up with 50-mile-an-hour winds, quite a distance from the storm, 300-400 miles away from the center of the storm. So they can impact large swaths of storms of an area. So next slide. Just to kind of give all the numbers in a table form here, there's 65% chance of an above normal season this year. There is some uncertainty, and I'll go through some of those reasons in a minute and what we're looking at to make the outlook. To review also for May 2021, we were 13 to 20 storms, 6 to 10 hurricanes, and that should actually be 3 to 5 major hurricanes, not 3 to 4. I can't type. Well, I can, but I had a typo. So that's May, and then the August 21st, August 2021 outlook. We did up the numbers because we had the busy early season, and we want to up our numbers to reflect that. And we ended up with 21 named storms, 7 hurricanes and 4 major hurricanes, the numbers in red there. I know the season was 148% of normal. So almost 1.5 times the normal activity for the overall season. Next slide. Putting this in perspective, 115, this year's forecast is for a 115% to 200% of normal. This would be our 7th consecutive above normal season, which would be extending the record period. We've not had, anywhere in the past, we've not had 6 consecutive seasons that were above normal. And that's going back to 1850. I only show from 1950 onwards just because it'd be too many lines to put on the plot if I went all the way back. Plus the data since 1950 is much more reliable because we were flying we had aircraft reconnaissance going into the storms. So some of the past data, there's a lot of bigger uncertainty bars with it. Something this graph does highlight though is that there was an active period from 1950 to 1970 where we had a lot of those bars in here getting into the above normal category, so being above that red line. And then in the 70s to mid 90s, you had a cool period in the Atlantic Ocean, and that actually had less tropical cyclone and hurricane activity. But then since 1995, we've been in a more active period. And that's one of the major factors that goes into the outlook. What period are we in, active or inactive? If we go to the next slide, we'll see kind of why that really matters. The number of major hurricanes is what really changes when you go from active to inactive periods. So then all of a sudden in active areas, you are about 1.5 times more likely to get a major hurricane, so 30% to 45% of hurricanes transition to major hurricanes. And again, major hurricanes are these storms with winds of 111 miles per hour and greater, category 3, 4, and 5. They can do catastrophic levels of damage. They can, if you lived through Andrew, or if you lived in, there's a lot of towns recently have, especially across Louisiana, have been, and Michael in Florida, where it made land in Mexico Beach in Florida, absolutely destroyed towns. And this is one of the bigger changes. So it's something we really, really want people to prepare now for, because if you prepare now, you're able to evacuate faster or recover faster should a hurricane strike your area. So next slide. The other thing that the activity era does is it changes landfalls. So the Gulf Coast, the right-hand set of bars on this plot are usually, almost every year, they're going to have a landfall. Almost every year. Somewhere along the Gulf Coast, there'll be a landfalling hurricane. But the Atlantic coast, during high activity eras, has almost a doubling of the odds for having a hurricane make landfall on the East Coast, which is kind of Key West up to Maine, so anywhere in that region. And these statistics go back to 1950 again, so 71 years of data. So that's really the biggest change, and that's why we want people to prepare now to understand what's coming for the season. So Gulf Coast, definitely, it's almost every year, but the Atlantic, there's quite a shift in the Atlantic pattern during active years. So next slide. And then overall, this is what we're seeing. We're seeing kind of the, if we look in the left-hand side of this plot, that's kind of what we're seeing this year. Warmer sea surface temperature conditions in the Atlantic, warmer in the North Atlantic, a stronger West African monsoon, which also gives us kind of lower amount of wind shear over the Atlantic and better and more favorable trade winds. So the left-hand side of this plot is what we're seeing right now. And that kind of went into the outlook for this year, as far as that's one of the major factors that went into the outlook, seeing this warm phase of the Atlantic multidecadal variability. So next slide. And the next slide. All right, so one of the other things we look at is the status of El Niño and La Niña. We can see that we are currently in a La Niña. It is robust. There's coupling with the atmospheric circulation over it. Although recently, as you can, there are some decoupling. There's some noise in the pattern. It's not as closely coupled. We're actually seeing the sea surface temperatures. They were about -1.1. They're only now at a -0.6. And if we look at the right-hand side in the middle plot, there is some kind of there should be a whole bunch of arrows going from right to left, right along the equator, but there's not as much. That is actually related to changes that happen on a month-to-month basis, and kind of it brought some westerly winds in there and kind of disrupted the El Niño or the La Niña circulation. Looking at the outlook for the next 2 weeks, we should actually be seeing a reversal in that and seeing patterns that will kind of reinforce the La Niña pattern. Top panel there does show where the precipitation in orange, the precipitation is less than normal in orange, and the precipitation is above normal in the blue areas there. So that's a hallmark La Niña signature, is to have less than normal clouds and rainfall over much of the central Pacific, although that one is shifted quite far to the west. So it will definitely have different implications for downstream than you would if that was centered right near the date line. Next slide. Looking subsurface in the ocean, if we just focus on the left-hand plot there, you can see that there is some warm water that has kind of made its way up towards the surface and kind of disrupted some of the La Niña signature, and that's kind of consistent with what we're seeing, where kind of this recent kind of change or just disruption to the robust La Niña. It's pretty normal during summertime to have, summertime's when you have normally your least amount of variance, in your kind of weakest reflections of either El Nino or La Nina in the Pacific, and then they kind of they're strongest December, January, February. So it's not uncommon to see some of this kind of variability week to week in there. But there's still a lot of cold water around in the Pacific, kind of off equatorial as well, not just right along the equator, which is where that plot is centered. So the odds for La Nina, again, we mentioned, are 54%, but the odds for an El Nino, which could cap the hurricane season, are quite low. Next slide. Speaking of that forecast, I got 54% chance of a La Nina during the August, September, October period, which again encapsulates about 90% of all tropical cyclone activity. Recent years, it's been 92% of activity has happened during August, September, October, but when you look long term, it's about 90%. This chart also tells us that there's a 54% chance of La Nina, about a 40-something% chance of, I have to look at the numbers and read them there, 43% chance of ENSO neutral, but only a 3% chance of El Nino. El Nino is what could come in and put a cap on the season, so there's only a 3% chance of that actually coming in. Neutral and La Nina kind of let the warm waters of the Atlantic and the active era, they kind of let that shine through. And sometimes La Nina can enhance that, but it's more that it just lets the more activity era kind of come through and not interrupt that pattern. So next slide. So there was the talk earlier on, I mentioned the point about having a potential third winter. Out of the prior 2 La Ninas, where they had the prior 7 times where we had back-to-back La Ninas, 3 of them ended up in El Ninos, 2 in neutrals, and 2 in more continued into a third La Nina. So 3 years of La Nina back-to-back is very rare. It's only 2 in 70-something and 71 years. We've only had 7 cases of double dip La Ninas in the 70 years. So these are not common events. There's not a lot of research, and there's a lot of talk about this, but there's not a lot of linkages saying back-to-back La Ninas mean even more enhanced La Nina impact. It's to the hurricane season. The hurricane season itself is more just what's going on this year from a La Nina or El Nino perspective. Hurricane season kind of doesn't have that much memory compared to last year. Things like drought and water supply have a much longer memory, and they are impacted by things from last year. Next slide. Looking into the models forecast that went into this, we have the North American multi-model ensemble on the left, which is about 100 of the supercomputer models that we run. Their average is right on the border for the La Nina or neutral. So that's where basically we're almost 50-50 between La Nina and neutral. But then when we take into account our statistical models, on which come to the right-hand side, and our best statistical estimate given long-term error statistics and how these models do in each month from each lead. Our consolidation in the turquoise plot there does show that June, July, August does show that some of that weakening, but then actually shows a return to the La Nina conditions, with an anomaly of about -0.6 to 0.7 during August, September, October. So the statistical models are a little bit cooler than the dynamical models. That's the takeaway from this. Next slide. And then what else we're looking at? So we've talked about the active era in the Atlantic. Then we talked about the La Nina kind of potentially allowing that to shine through and reinforcing it. And then local to the Atlantic, the wind patterns. Left-hand side is the winds at about 8 to 10,000 feet over the Atlantic Ocean and into Western Africa. That is showing a pattern that is favorable for stronger waves to come off of Africa and to have a more favorable environment because that shows reduced trade winds over the Eastern Atlantic and more inflow into the West African monsoon region, which would allow these waves to be more robust when they come off of Africa. It allows for a wetter atmosphere over Western Africa, and so those waves can have the waves themselves that are kind of waves in the wind. They can then have a feedback with the amount of rainfall and then the pressure, and it's a positive feed forward loop there where they get stronger and stronger. There's kind of nothing there's less to disrupt them. So that's at about 10,000 feet. The right-hand plot is showing winds, or a portion of the winds, up at about 60,000 feet. So the kind of the top of the atmosphere. So the left-hand plot is showing the winds coming in the low levels. The right-hand plot is showing winds going out at the upper levels. And that is showing us, again, more signatures of a strong West African monsoon. where that wind is coming up and rising. You're having a lot of rising motion over Western Africa, creating those thunderstorms, allow it and having a favorable environment for tropical waves to kind of continue and have robust thunderstorm activity with them. That part is a little bit weaker. It's kind of been bouncing around and looking close to 2021. That plot over, it's a little bit weaker over Africa. That kind of the strongest anomaly there is kind of centered just off the coast of Africa. Last year it was further inland. So that may be a change, and that's why the forecast, the 14 to 21 named storms, it's kind of just centered slightly lower than last year's 21 named storms. So we didn't want to go full bore because we are seeing a lot of signals that are for strong, but not over the top. Not everything is showing for, the strongest of strong, another kind of record type season. Last year was the third highest amount of named storms on record. So even if we get 19 named storms, we'd still be within a top 10 kind of year. So next slide. Another thing we look at is sea level pressures, which is pressure very close to the surface of the ocean. And the blue shading here indicates that it is below normal across much of the Atlantic. Tropical storms are low pressure areas. So they're just a very concentrated area of low pressure. But when they're in an area of already lower pressures, it's easier for them to develop. They're not pushed around as much at the low levels and separating it from the upper levels. So this is, again, another favorable pattern for an above normal season. Next slide. Vertical wind shear, another thing we look at, which is kind of change in winds from low levels to upper levels. So the models here are all showing favorable signs, which is anything in blue on these plots would be a favorable area for tropical cyclone development. And this is all model forecasts here. Climate forecast system on the left, that's about 80 model runs. The one on the top right is about another 100 model runs. And in the bottom middle is so just a sample where we showed that that's the UK Met model. So there's a lot of international partners help work on this with us, because Atlantic hurricanes will recurve and eventually can eventually impact the UK and West and Europe as well. Some of the things to take away from this plot, again, the blue areas are favorable. On average, the main development region does have a favorable shear profile. And the North American multi-mile ensemble, it actually has the second lowest shear, which is favorable, in its 30-year record. So there are some strong signals from some of these models. Next slide. And then this is kind of all the tools that we're looking at. I know it's a lot of numbers, but we are looking at statistical tools, regressions, analogs. We do a lot of dynamical models going to this. And the guidance mean 13 to 19, and our forecast is for 14 to 21. And the rest of our numbers are kind of aligned with the actual mathematical guidance that we have. Next slide. I think that's all I had. So the summary: 14 to 21 named storms, 6 to 10 hurricanes, 3 to 10 major hurricanes. But it's kind of quiet out there right now. There's the one potential formation, but that looks like it should take a very southerly track. So take the time to prepare now. Everything you can, even from where's your family, where are they likely to be in August, September, October, businesses, insurance policies. I had a talk yesterday with an insurance group. Look at them now. They don't always go into effect immediately. So think about things like that. Think about gathering supplies now. We know supply chains are kind of strained right now. It may not be easy to get things on quick notice when a hurricane does approach. So take the time now and stockpile what you can reasonably. Don't go buy everything, but take the time to think through what you might need should a hurricane come to your region. So that's all I had.
That's fantastic. Thank you so much, Matthew. My name is Meredith Muth. I work at NOAA's National Integrated Drought Information System, NIDIS. NIDIS co-organizes this webinar series with the Southeast Regional Climate Center and the National Weather Service. We're really pleased you joined us today. Just a reminder, if you have any questions, any of our panelists, please enter those into the question box. Matt, just giving you a heads up that I've started to post so that you can see some of the questions that I'm going to be reading out loud. Just give you a little heads up. Before we get to the Q&A, just a reminder that we will be sending out an email link to a webinar recording and key takeaways. Feel free to share those and post those as well. Our next webinar will be on July 26th and includes harmful algae blooms, which we haven't talked about in this webinar series, get a little bit to the wet side. And then we'll be following up with a little climate and heat interaction, and then some new products and tools from the U.S. Geological Survey. When you leave today, there'll be a quick survey asking for any comments on how we can improve this webinar. Feel free to put any suggestions, including topics you want to hear more about, and we would welcome suggested names of speakers as well. And with that, one more thank you to our presenters, Matthew from the Climate Prediction Center of the National Weather Service, Jeff from the Southeast Regional Climate Center, Sandra from the Southeast Regional Climate Center, Jeff from the Southeast River Forecast Center, and Pam from the University of Georgia. And with that, let's go ahead. We have quite a bit of questions. If we don't get to all of them, that's okay. We will make sure that we contact you offline. If that's okay with our panelists, I can share the questions then. So Matthew, I'm going to start with the first question. Will future storm forecasts be able to identify how much rainfall moisture the storm may bring with it to better plan for inland flooding potential of each storm, especially for Gulf storms that move into the Appalachians?
That is a huge concern, is inland rainfall, is inland flooding and the devastation that comes with that. Yeah, so one of the things, NOAA, we have a precipitation grand challenge, how to improve our precipitation forecasts at every scale from, one day into the future out through seasons and months into the future. So the latest forecasts from the Weather Prediction Center and your local forecast office, they do really have very detailed information out through day 7, and there are specific rainfall forecasts that come out in the package, in the forecast package for each tropical cyclone. So we're used to the warning, the cone, and the track forecast in the Hurricane Center. Usually associated with that, if one is making landfall, will be a very specific rainfall forecast for that storm and that hurricane, or if it's or major hurricane if it reaches that strong. So yeah, so the forecast for those are there, and there's a lot of research going into them, including artificial intelligence, running these our models at higher resolutions. So yeah, there's a lot of work on that stuff.
Great. Matthew, next question. Can you say more about the accumulated cyclone energy metric, please?
Sure. So the ACE, accumulated cyclone energy, it takes the advisories that come out from the National Hurricane Center every 6 hours. In that advisory, they list the wind speed, the maximum wind speed for the storm. You take that value that comes out every 6 hours, square it, and then sum them across the entire tropical cyclone season. So any storm that formed that year, you would add into that value. That's how we calculate ACE. Not sure if that fully answered the question, but it accounts for maximum intensity and also duration of storms.
I didn't know that. I learned something today too. Next question, Matthew. Is there any research into if and how climate change is impacting the likelihood of having multiple sequential La Niña years?
There are many papers that have focused on what will happen with the frequency of La Niña and El Nino, or neutral during a climate change scenario. The best person to answer that question would be Michelle LaRue, the lead of NOAA's ENSO team.
Okay, great. Next question, and I can put that information in chat if the person who asked the question is interested. Next question, and this relates to ACE as well. If I understand correctly, a seasonal forecast, including a high ACE forecast, can lead to double the East Coast odds of hurricane landfall. What is the mechanism for steering the storms during these conditions? Is it a shift in the Bermuda Ridge?
Yes and no. So yes, some years the high pressure that is over the Atlantic will kind of be favorable for steering those storms towards the East Coast and the Atlantic coast. Other years, it's not that favorable to steer them there from the Bermuda, which is defined as a low, lower levels, but the mid-level circulations can actually steer the storms there. Or you just get more formations closer to the coast, so they have nowhere to go but run into the coast. So it's kind of variable every year. It's not just high ACE as a result of favorable conditions, and then the Bermuda Ridge will just drive them towards the East Coast.
Great, thank you. And we still have time for a few more questions or comments if you'd like to go ahead and add. And again, that could be for any of our presenters. We also talked quite a bit about drought today as well.
Can I also add that as a former Drought Monitor author, I love the local reports. So I was really glad to see that map had more dots on it. So please make the reports from every state around. They are absolutely valuable pieces of information.
Oh, excellent. Glad to hear that. I didn't know you were a former reporter. Matthew, there's a question on how is the best way to get in contact with you. Can we include your email in the webinar recap, or you can put it into the chat right now?
Sure. Yeah, my email, absolutely the best way, being that we are teleworking. That's my email. I will request if anyone is media to go through public affairs. They do coordinate the schedule for that.
Okay, excellent. And I really appreciate your early warning, get ready, get prepared messaging that always comes from the National Weather Service. I remember spending the night in a bathtub during Hurricane Andrew in Miami, and I need to call my mom and dad right after this. Here's one more question I have here. Will there be an inclusion of rainfall impacts within the vicinity of a tropical cyclone, similar to the wind radii product?
As far as breaking down where maximum rainfall is likely within relative to the tropical cyclone, like there is for the wind radii in each quadrant, probably not. But there are the products from the Weather Service and your local weather forecast office that do include the specific amounts of rainfall likely at each location. There's that's the collaborated forecast that comes out from the Weather Prediction Center, the Hurricane Center, and the local weather forecast office. There are very specific, and those are usually given out at about every I think 2.5 kilometers. So they're very highly specific once they are finally developed. So that's done every 6 to 12 hours. That outlook, those come out.
Well, we got through all of the questions. I'll keep it open for another minute. Before we close out, do any of the panelists have any other last remarks they would like to share at this time? I would like to say, let everyone know that Sandra Rain, who's been with us since we first started this webinar series over 2 years ago, and she's the one who gave that the first presentation, is moving on to another job at NOAA's National Centers for Environmental Information. So hopefully we'll have her back soon as a special guest presenter, and stay tuned for a replacement. Huge boots to fill, and you've just been a tremendous help in everything. So thank you, Sandra, for your time and joining us every month. And with that, I don't see any more questions, so I will just say, again, we look forward to seeing you next month. Thank you again to our presenters, and have a wonderful holiday weekend. Goodbye.